Today we are going to talk about the order of operations. Now, in previous years of school, you have worked on using the order of operations, and this year we are going to add in the final component, exponents. By the end of class today, it is your goal to be able to evaluate expressions that include exponents using the order of operations. Let's start off with some vocab. A numerical expression. A numerical expression is an expression containing only numbers and operations. For example, 3 plus 5. This has numbers, it has operations, there are no letters, no equal signs, just numbers and operations. Now, the word evaluate is the word we use when we're dealing with expressions. That means to find the value of that expression. So if I was going to evaluate this numerical expression of 3 plus 5, my value would be 8. The order of operations are a set of rules, as you know, that determine the order in which we calculate or evaluate that numerical expression. So let's go through what those steps are. We use the term Pemdas to help us remember. There's a couple of different rhymes to help you remember. Use what you are used to, use what you would like to help you remember the order. Let's start with that P. P. Your P stands for parentheses and grouping symbols. So that could be regular parentheses. It could be brackets of different sorts. So the first thing that we look for are any of these grouping symbols. If you have more than one set or sets around each other, you would start at the most center. We can take a look at some examples. So always starting with those parentheses, those grouping symbols. Next, we move to look at our exponents. Remember, our exponents are the little guys up to the right. Next, we have our multiplication and our division. Remember that with our multiplication and division, we move left to right. So it doesn't matter which one comes first if we're looking at an expression. Whichever one comes first, when we look left to right, we do the left one first. So it doesn't matter if it's multiplication, it doesn't matter if it's division, whichever one it is what we do first. And lastly, we've got our adding and subtracting. Same thing as with multiplication and division. Adding does not always come first. We look at our expression left to right and we solve, or we evaluate that way. We evaluate the furthest left addition or subtraction. So let's do an example here together. I've got the numerical expression 7 plus 3 squared times 2. So I start with my parentheses. I go down my list. I don't have any parentheses here, so I skip that and move on to exponents. I do have exponents. Remember, with our order of operations, we go line by line. We keep everything incredibly organized so we don't lose anything. Okay, so I start with those exponents. 3 squared is 9. Now I bring down everything else. I cannot lose it. And if I leave it up here and just try to evaluate continuing down, I'm going to lose something. Okay, so we keep everything organized, going line by line. I've finished with my exponents. There are none left. So next I have multiplication and division. I only have multiplication, so that's what I do next. 9 times 2 is 18. Now I bring down my 7 plus. This is the last step that we have, so I go ahead and do it. 7 plus 18 is 25. So the value of this expression is 25. We've got 2 more examples here together. Before we begin on this next one, sometimes it's helpful to write the letters of Pemdas down next to each problem. Then I can check them off as I go. Let's try. I start with my parentheses. I do have parentheses here, so I need to look here first. Once I'm inside my parentheses, sometimes there's multiple steps. I need to continue down the list within my parentheses. So I have, on my next on my list is our exponent. So that's what I do first inside those parentheses. 2 cubed is 8. Now I need to bring everything back down. I can't lose my parentheses yet. I still have things to evaluate inside. Okay, I am not yet done with my parentheses, so I can't get rid of that yet. Still inside those parentheses, 7 plus 8 is 15. Again, I'm going to bring everything else down. There's nothing left to evaluate in my parentheses, so I can lose those now. All right. I finished with my parentheses. I am done. I take a look. There are no more exponents. I am done. And then I've got multiplication division. Well, I have both. So I need to start at the left and move to the right. When I start at the left, the first operation is division. So that's what I do first. 30 divided by 15 is 2. Now I bring everything else down, and I'm left with my multiplication. 2 times 6 is 12. I have got nothing left to evaluate. I finished my multiplication and division. There was no addition and subtraction, so the value of this numerical expression is 12. We've got one more example today. Here we see that the exponent is inside the parentheses. It's attached to that 2. Here we notice, oops, that's not supposed to be there. This exponent is outside of the parentheses. So we're going to talk about how that's different today. Again, if you want to write out that Pemdas down the side to help you, you may. If you don't need it, you may skip that. Your call. Okay, so I start with my parentheses. Inside of my parentheses, I've got subtraction. That's all I have inside. So I do that first. 5 minus 3 is 2. Then I go ahead and keep everything else bringing it down. Now that exponent was outside of the parentheses. What that means is I need to evaluate inside the parentheses, and then I can square the difference of those numbers, okay? So technically I don't need those parentheses here anymore. There's nothing left to evaluate inside the parentheses. I'm done with that, so I move to my exponents. 2 squared is 4. Bring everything else down, and I'm done with my exponents. Next up, I have multiplication and division. Here I only have division. 60 divided by 4 is 15. Again, I bring everything else down. I'm done with my multiplication and division. I add and subtract last. I only have addition, leaving me with a value of 22. So the value of this expression is 22. So we follow these steps in order every single time. We pay attention a little bit more carefully to those exponents and evaluate those exponents as we normally would, just within this larger expression.